This lesson is on correlation and causality. We're going to continue looking at scatter diagrams, which were introduced in the previous lesson, but extend it to looking at how to interpret them and identify different types of correlation. We will also highlight the distinction between correlation and causality. An important term to understand is correlation. Now, correlation is a relationship or association between two sets of data. Remember, we introduced association in the previous lesson where we said that two variables are associated if they have a relationship. Now, there are different types of correlation to describe this relationship, which we're going to look at now. Three main types of correlation you need to be familiar with are positive correlation, negative correlation, and zero correlation. Positive correlation is where, as one variable increases, the other variable also increases. Negative correlation is where, as one variable increases, the other variable decreases. And zero correlation is where there is no relationship between the variables. The points are randomly scattered. Let's look at a few example scattered diagrams to see what these types of correlation look like. Here is an example scatter diagram showing a strong positive correlation. It's actually an example we used in the previous lesson on scatter diagrams. As temperature increases, the number of ice cream sales also increase. However, even a strong correlation such as this does not mean that temperature causes ice cream sales. We'll come back to consider this later in the lesson. Not all scatter diagrams have points that show such an obvious correlation, so we use the term strong positive correlation for a diagram such as this. This is what we call a weak positive correlation. There is just about an upward trend of data points. Although it's important not to join up the points on a scattered diagram, sometimes it can help to think about drawing a bubble around the points to see if there is a weak correlation. Here, if we draw a bubble around the data points, we can see that there is a trend from bottom left to top right, indicating a weak positive correlation. Now let's look at an example of strong negative correlation. As time spent on social media increases, well-being score decreases. We can see the line made by the data points goes in the opposite direction to the positive correlation. This is also a very clear, almost straight line of data points, so we would term this a strong negative correlation. This scatter diagram is showing a weaker negative correlation. There's just about a downward trend of data points from top left to bottom right, the direction of a negative correlation. Again, if we draw a bubble around the data points, we can see this downward trend more clearly. This scatter diagram shows no correlation. We can see the points are all scattered about randomly and aren't close to each other, forming a line or pattern. Even if we drew a bubble around the data points, there doesn't seem to be any upward or downward trend. So there's no correlation. The two variables of amount of chocolate eaten and the daily time spent studying are not related. The correlations we have been looking at are referred to as linear correlations, as all the data points lie on or close to a straight line. Here is our example from earlier showing a strong positive linear correlation between temperature and number of ice cream sales. We can see it's a linear correlation as the points all lie close to a straight line. Now, nonlinear correlation is an alternative type of correlation where there is a relationship between two variables, but the points lie together forming a curve rather than a straight line. Here we can see an example of a non-linear correlation with the data points close together curving upwards. It's useful to be aware of non-linear correlation. However, the focus on interpreting scatter diagrams and correlations in this course will be linear correlations. Within the lesson so far, we have talked about variables being related or correlated to each other. However, this doesn't mean that there is causality. Let's consider this in a little more detail. A causal relationship is where a change in one variable directly causes a change in another variable. Now, for causation to exist, there must be a correlation. However, we need to be careful because not all correlations are causal. There are some questions that we can ask ourselves when interpreting scatter diagrams and correlations in considering whether the correlation is also a causal relationship. Firstly, does the relationship between the two variables make sense? Is there a reason why one variable would cause the change in the other variable? And is there anything else that could cause the change? Let's look at a couple of examples and think through these questions. Returning firstly to our earlier strong positive correlation example of temperature and the number of ice cream sales. Does the relationship make sense? Yes, it makes sense that there would be more ice cream sales at higher temperatures. Is there a reason why one variable would cause a change in the other variable? Yes, the hot temperatures would make people want to buy a cold ice cream to cool down. So yes, it makes sense. Is there another explanation? No, not that I can think of. So yes, this is probably a causal relationship. However, correlation does not mean causality, even a strong correlation. And this is a crucial point to remember and incorporate into answering questions. There are many variables that can show a strong correlation, but do not have a causal relationship. Let's look at another example. There is a strong positive correlation between the number of ice cream sales and the number of shark attacks. Does this mean the sharks are attacking to eat ice cream? No, of course not. Let's work through the questions. Does the relationship make sense? No, not really. Is there a reason why one variable would cause the change in the other variable? Are sharks attacking to buy or eat ice cream? No. Is there anything else that could cause the change? Yes, hot weather. Hot weather would mean more ice cream sales, and hot weather would mean more people swimming in the sea. So the likelihood of shark attacks increases. So both ice cream sales and the number of shark attacks could increase due to another variable. This is therefore not a causal relationship. Ice cream sales do not cause shark attacks. This final section is only relevant for those studying for the higher tier. If you are studying for the foundation level, then you should fast forward the video to the learning objectives titled What You Need to Know at the end of the video. So now we're going to move on to consider the impact of multiple factors. As mentioned, this area of the syllabus is only applicable to the higher tier. When we talk about multiple factors in relation to correlation, it is where there are multiple factors that interact to cause variables to change. So we may identify correlation between two variables due to both variables depending on a third factor. The example we looked at earlier with ice cream sales and the number of shark attacks had another factor involved: hot weather. So this was an example where multiple factors were involved. Let's look at another example. Here we have a scatter diagram showing a strong positive correlation between hand size and quality of handwriting. Does this strong positive correlation mean that a larger hand size causes better handwriting? Not necessarily. Remember, correlation does not mean causality. Let's think through our questions for interpreting correlation to determine whether a causal relationship is likely. Does the relationship between the two variables make sense? Does a bigger hand size always mean better handwriting? Does a small hand always mean worse handwriting? No, this relationship doesn't really make sense. Secondly, is there a reason why one variable would cause the change in the other variable? Why might hand size cause change in quality of handwriting? No, there isn't really an obvious reason for this. Is there another explanation? Is there anything else that could cause this change? Yes, age. Age is a third variable that could cause the change in both hand size and quality of handwriting. So as age increases, hand size also increases. As age increases, quality of handwriting increases, particularly if the sample on which this scatter diagram is based was on children. So age is a third factor that could affect both hand size and quality of handwriting. The strong correlation then is not a causal relationship. Hand size does not cause better handwriting. In terms of what you need to know in relation to correlation and causality, you need to be able to interpret data presented in the form of a scatter diagram. You need to know and apply the key terms of positive, negative, zero, and causation. To recognise positive, negative, and zero correlation by inspection. To describe and make comparisons of correlation strength by inspection, so saying whether it's a strong or weak correlation. And know that correlation does not necessarily imply causality. And if you're studying at the higher tier, also know that multiple factors may interact. We will continue to refer to scatter diagrams and the types of correlation in the lessons during the rest of this unit, so you will get lots more practice. For now though, that's it on correlation and causality, so have a go at the questions in the quiz that follows this lesson.